Okay, so today we're going to be talking about function notation and evaluating functions. So equations that represent functions are written in function notation. So if you have the equation y equals 4x minus 1, we know that this is a function. If you did the vertical line test, you would be able to tell that it's a function. So you could write it in function notation. The way you would do that is f of x is equal to 4x minus 1. And this is read as f of x. X, in this case, would be the input, and f of x would be the output. So if you look at these two examples, you'll notice that y and f of x are the same thing. One thing about function notation is that it actually has its benefits. One of them is that it's especially useful for finding a value in the range that corresponds to a certain domain value. So this is when we are evaluating functions. So the example that they give us here is if f of x is equal to 4x minus 1, find f of negative 7. You'll notice here that they're replacing the x value with the negative 7. So they're asking you then to evaluate this entire function when x is equal to negative 7. So what you would do in this case is you would plug in negative 7 anywhere you see an x. So it would look something like this. So f of negative 7 is equal to 4 times negative 7 minus 1. Notice that I plugged in negative 7 anywhere there's an x, including the x within the f of x. You have to be very specific. That's actually another benefit to using function notation in that it's very specific. They're trying to find the f of negative 7 value. So it tells you right off the bat what you're looking for. So f of negative 7 then would be negative 29. So this would be your whole answer. You can't just say negative 29. You have to write that f of negative 7 is equal to negative 29. You have to be very specific here. So now let's look at some examples here. Evaluate each function for the given value. So for example 1, we have f of x equals x plus 7, and they want us to evaluate the function when x is 5. So they want us to evaluate f of 5. So we're going to go ahead and do that. First step is to plug in the 5 anywhere you see an x, and then you'll simply simplify. So your final answer would be f of 5 equals 12. You have to include the entire thing. If you only say 12 or only say f of 5, which I don't know why anyone would do that, it would be wrong. So let's go ahead and try example 2. For question 2, it says g of x equals 3x minus 8, and we're finding g of negative 3. So what I'm going to do is I'm going to plug in a negative 3 anywhere I see an x, and then I will simplify. So then my final answer here would be g of negative 3 equals negative 17. All right, let's go ahead and try example 3. So we have h of x is equal to 2 over 3x minus 1, and we want to evaluate h of x at when x is 9. Notice here that it doesn't necessarily have to be f of x. You could use whatever letter you want. The standard is, or the default is usually f of x, but you could use really any letter. So over here they're using h of x. They're just kind of naming that function h, or h of x. So let's go ahead and do that. We're going to plug in 9 anywhere we see an x. All right, once you simplify, you will get h of 9 is equal to 5. So basically 2 over 3 will simplify to 6, and then 6 minus 1 is 5. So that's how I got 5. All right, let's try the next example. So we have f of x equals x squared minus x. Once again, I'm going to plug in the negative 4 anywhere I see an x. All right, notice here that I put the negative 4s in parentheses, because if I didn't do that, I would think that this is 4 squared, and then I'd multiply everything by a negative, and then I'd end up with a negative 16. But really, I'm squaring the entire negative 4. So then it would actually be negative 4 squared, which is positive 16. So it is very important when you're doing evaluating functions, that you put everything in parentheses. Otherwise, you will get confused and get the wrong answer. So anyways, I'm going to go ahead and simplify this. So I end up negative 4 squared is 16, and then minus negative 4, two negatives make a positive, so then it becomes plus 4. 16 plus 4 is 20, so then my entire answer would be f of negative 4 equals 20. Alright, so I want you guys to pause this video and try the next 4 on your own, and then we'll go over them. Alright, so for question 5, we're finding f of 5 when f of x equals negative x squared plus 6x minus 4. So first thing we have to do is plug in the 5 anywhere I see an x. So 5 is my input value. So I have f of 5 equals negative, and then parentheses 5 squared plus 6 times 5 minus 4. So I end up with f of 5 equals negative 25 plus 30 minus 4. And when I simplify that, I end up with f of 5 equals 1. Now notice here I plugged in the 5 in for the x, but that negative is on the outside, unlike the first one where I was plugging in a negative. This time I'm plugging in a positive into an already negative x value, so you would leave that negative on the outside. Anyway, so I would end up with f of 5 equals 1. Let's look at question number 6. So for question 6, I'm plugging in negative 8 anywhere I see an x value. So I would end up with g of negative 8 equals negative 1/2 times negative 8 plus 9. If I multiply negative 1/2 times 8, I end up with a positive 4. And then I get plus, and then I bring down the 9, so plus 9. So I get g of negative 8 equals 13. For question 7, I'm plugging in a negative value in for all of the x values. So I have f of negative 5 equals 2 times negative 5 squared, where the negative 5 is included is all being squared. And then plus 4 times negative 5 minus 9. So I start off with the parentheses, so I'm going to do negative 5 squared. I end up with 25. And then I have 4 times negative 5, that's just negative 20, and then I bring down the negative 9. So then 2 times 25 is 50, and then I bring down the negative 20 and the negative 9, and when I combine all of those, I end up with f of negative 5 equals 21. Alright, so for question 8, I have g of x equals the absolute value of x minus x squared. And I am evaluating it at g of negative 7. So if I plug in negative 7, I'm evaluating the whole function at negative 7. So if I plug it in, I end up with g of negative 7 equals the absolute value of 7 minus parentheses negative 7 squared. And I end up with g of negative 7 equals the absolute value of negative 7 minus positive 49. And so then when I simplify that, I end up with g of negative 7 equals the absolute value of negative 56, which the absolute value of negative 56 is just going to be positive 56. So then my final answer is g of negative 7 equals 56. Alright, so for this next question, we have f of x equals 4x plus 11. And this time we're asked to plug in an entire expression, c plus 7. It's done the exact same way, except you're just going to simplify until it can no longer be simplified. So I'll show you how to do that. So start off by plugging it in, and then simplifying the right side. So you get, you're first going to start off by distributing the 4. You would end up with 4c plus 28, and drop the 11. So then you're going to combine like terms, so you end up with 4c plus 39. So you have f of c plus 7 equals 4c plus 39. You can't simplify that any further, so this would be your final answer. Alright, let's try question number 10. So we have h of x equals negative 9 minus x, and we are going to find h of 2k minus 5. So again, I'm going to plug in anywhere there's an x, I'm going to plug it in with 2k minus 5, and then I'm going to simplify. So when I simplify it, I start off by distributing that negative first, so I end up with negative 9 minus 2k plus 5, And then I go ahead and simplify the right side. So then I have h of 2k minus 5 is equal to negative 2k minus 4, and that's my final answer. All right, so for questions 11 through 16, what we're going to do is use what we have on the left side, use the three functions we have on the left side to answer these questions. So I'm going to do question 11 with you. So it says f of 4 plus 9. So what I'm going to do is I'm going to evaluate the function f of x with 4 when x equals 4, and then after I do that, I'm going to add 9 to it. So I'm going to show you how that's done. Alright, so they're asking us to first find f of 4. So I have to know which of those three functions to use. Since they're asking me to find f of 4, I'm obviously going to use the f of x function, and then I'm just going to plug in 4 and find that first. Once I find that, I will add the 9. So let me show you how that's done. Okay, so I first started off by finding f of 4, and once I plugged in the 4, I ended up with f of 4 equals negative 4. But it tells us that they want f of 4 plus 9. So we already found f of 4 is negative 4, so now all I'm going to do is do negative 4 plus 9, and then I get my final answer, which is 5. And this would be my final answer. Alright, so let's try example 12. So they're telling us to do negative 2 times g of negative 5. So instead of doing this in two separate steps, I'm going to do it all in one step. So I'm finding g of negative 5. I know that I'm going to use the g of x function since we're working with the g, right? So I'm going to take g of x, and anywhere I see an x, I'm going to plug it in. So I'm not going to use the g of x portion. I'll just do x, which is negative 5 squared plus 2 times negative 5. So all I basically did here was plugged in negative 5 for my g of x function, and I'm multiplying that whole thing by negative 2. So when I simplify that, I start off with the parentheses because we are doing PEMDAS. So I'll start off with the negative 5 squared, which is just going to give me positive 25. And then I have plus 2 times negative 5, which is just negative 10. And then I bring down that negative 2. So then I have negative 2 times 25 minus 10, which is 15. So that just ends up giving me negative 30. And that would be my final answer there. Alright, I want you guys to try questions 13 and 14 on your own, and then unpause this video when you're ready. Alright, so if you did this, you have g of 4 plus a g of negative 1. So for both of those functions, we're using the g of x function, and we're just evaluating x at 4, and then adding it to the, I guess, the evaluation of g of x at negative 1. So I went ahead and did that. I know that my g of x is x squared plus 2x, so I plugged in a 4 anywhere there was an x. So I got 4 squared plus 2 times 4. It's important that you keep that in parentheses so that you don't get confused. And then plus g of negative 1. So I did the same thing. I plugged in negative 1 anywhere I saw an x. I made sure to use parentheses so that I don't get it confused. So I have negative 1 squared plus 2 times negative 1. And then I simplified each of the parentheses. I got 16 plus 8 in the first parentheses, and then 1 minus 2 in the second parentheses, and then I simplified. I got 24 minus 1, and then I ended up with 23. For question 14, I have 3 times h of 2, and then minus f of negative 9. So I'm using two different functions here. I have the g of x function, and I have the f of x function. I'm going to start off. I know that I'm multiplying the entire h of x function by 3, so I'm going to keep that out in the front to show that I'm multiplying it. And then inside of the parentheses, I'm evaluating h of x at 2. So I plug in, anywhere I see an x, I plug it in with 2. So I get negative 5 halves times 2 minus 1. And then for the second one, I have minus, and then I'm putting the whole thing in parentheses. And I'm using the f of x function. So I'm evaluating the f of x function at negative 9. So anywhere I see an x, I'm going to plug in 9. So I have minus 8 minus 3 times negative 9. And then I'm just going to simplify everything in the parentheses first. So I have negative, for the first parentheses, I ended up with negative 6. So then I also dropped the 3, so I ended up with 3 times negative 6. And then for the second parentheses, I got minus, and then open parentheses, 8 plus 27, which ends up being 35. So then it's negative 18 minus 35, which gives me negative 17, which is my final answer. All right, so for questions 15 and 16, these are a little bit different. Up until this point, we evaluated the function when we were given the x value, or the input. For questions 15 and 16, we're dealing with the y value, or the output, and finding x. So these are actually a little bit harder. But I'm going to show you how to do this, and then we're going to go over this again in our next lesson. So, if f of x equals negative 13, find x. So, it's telling us that the entire function f of x is equal to negative 13. Remember at the very beginning of this lesson, I said that f of x and y is the same thing. So, if you want to think about it this way, you could say that f of x is y, so then I can just plug in negative 13 for the entire y value, or the entire function. So, that's what I'm going to do. I have negative 13 equals 8 minus 3x. And then to find x, I'm just going to solve for x. So I'll go through my solving steps. I'm going to start off by subtracting the 8 on both sides. So when I do that, I end up with negative 21 equals negative 3x. So I'm going to divide both sides by negative 3. So I get x equals 7. All right, let's go ahead and try this next example. So for this next example, it says, if h of x equals 39, find x. Once again, I know that the entire function h of x equals 39. So that means that the y value for that function is 39. So if I go in, I'm going to replace the entire h of x with 39 and solve for x. So I have 39 equals negative 5 over 2x minus 1. And I'm just going to solve for x here. So I'm going to add 1 on both sides. I end up with 40 equals negative 5 over 2x. To isolate the x, I'm going to multiply both sides by the reciprocal of negative 5 over 2, which is negative 2 over 5. So then the fractions here cancel, and then on this side, negative 2/5 times 40 is just negative 16. So then negative 16 equals x. Alright, so for this next question, we have an application type problem. It says anthropologists use the length of certain bones in the human skeleton to estimate the height of the living person. One of these bones is the femur. To estimate the height in centimeters of a female with a femur, the length of x, with a length of x, the function h of x equals 61.41 plus 2.32x can be used. Find h of 46 and explain its meaning. So once again, you are going to plug in 46 for x because it's inside of the function, therefore it is the input, which is the x value. That's kind of one way I like to think about it. So if it's inside of the function, we're dealing with the input. If it's outside of the function or the whole function, then we're dealing with the output. So anyways, we have h of 46, so I'll plug in 46 anywhere I see an x. So I used a calculator here, and I got that h of 46 equals 168.13. So this basically means that a femur, if they find a femur with a length of 46, then the height will probably be approximately, the height of the entire skeleton would probably be somewhere around 168.13. For this next section, we're going to be evaluating given a graph. So for both 18 and 19, we aren't going to have any where they give us the y value and we're finding the x. We won't actually do that until our next unit, or our next lesson rather. So all of these examples are when you're given the x value. So let's look at this first example, question 18. We have this parabola, and for a, we're told to find f of negative 3. So basically what this means is, what is y when x is negative 3? So the first thing we're going to do is find where x is negative 3, which is right here, and then find the corresponding y value. So my corresponding y value is at 2, so then f of negative 3 in this case is 2. For b, we have f of 1. So I'm going to find f of 1, so I'm going to find where x is 1, which is right here, and find the corresponding y value. In this case, f of 1 is also 2. Alright, so for this next one, we're finding f of 0. So we're going to find the corresponding y value for when x is 0. X is 0 here, so my y value is at 1, 2, 3, 4, 5. For d, we're trying to find f of negative 2. So whenever x is 2, we're going to try to find the corresponding y value. So here's here's 2. So I'm going to find the corresponding y value. That's at negative 2. Alright, go ahead and pause this video and try number 19 for yourself. Alright, so this is what you should have got. F of negative 4 in this case is 2. So if you look for negative 4, 1, 2, 3, 4, the corresponding y value here is positive 2. For 0, we have f of 0 is right here. The corresponding y value is also 0. For c, we have f of 2, so I'm going to find where x is 2, and I'll find the corresponding y value at negative 2. For d, I'm going to find 5 when x is 5, and the corresponding y value here is negative 1.